Hey guys, in this video, I will go through the steps to check big objects in a video. For example, checking boxer in a video of boxing match. If we use the usual way by calling model.check from, for example, Ultralytics, we often have two issues. The first issue is that unwanted objects, which are small objects like audience, will be checked and will be drawn on every frame. The second issue is that the drawing of main objects, which are the boxers, will be skipped at certain frames due to problems like occlusion. First, I will illustrate this issue by calling the built-in command model.check from YOLOv8. So here are a few imports, and I load the YOLOv8 model, also print out the number of parameters. And in order to get the check of some video, it's quite simple. We simply call model.check on the path to the video. So first, let's see how this works. So here we can see already that the audience are drawn. And the next problem is Tang disappear because he was occluded by Ryan and he was not detected by the model. All right, so through the video just now, we see that there are two problems, two unwanted problems that arise. So one is the drawing of the audience, and the other one is the drawing of the boxers will be skipped at certain frames. So perhaps let me close myself out here for the space for the code. So two problems we want to solve. The first one will be detect large objects in a video. Well, I'm not sure if there are simple solution for this, but here my observation is quite simple. That is, large objects often have height or width relatively large compared to the original image height or width. For example, as we have seen just now, the boxer usually have height or width at least 1/3 of the image height or width. So based on this criteria, we can filter out those detection which give the main object to the video. So in this detect function, I pass in the image array and I pass in the ratio. So here the ratio I set to 1/5. That means whenever an object that was detected having height or width bigger than 1/5 of the image height or width, it will be deemed as a large object. Result is a list that stores the result, and here I want to return a list that contains the bounding box in format XYWH. That means the center together with the width and the height, confidence score, and classification index. First, we extract the height and the width of the image array. We do prediction with the YOLO model, so we simply call model.predict. Here I set confidence score to 0.1 because I want first detect all possible objects in the image. After this, the small object will be filtered out. So note that this model.predict return a list, and in this case we only have one image array, so the list only has one element. And here I want to extract out the exact detection for this image array, which is also the zeroth element of the list. And next, we extract all the bounding boxes, the confidence scores, and the classification index. We loop through all these, and whenever we have the case where the height of the bounding box, the width of the bounding box is bigger than width time ratio, or the height is bigger than height time ratio, we deem that as a big object we want to detect. So we append the results. We append this tuple to the results, and then we return the result. So this function is just a very simple function to detect large objects in an image. So with the first problem solved, now we will focus on solving the second problem. That is we want to draw bounding box on all objects. Not only drawing bounding box on object, we also want to check all the objects across all frames. So the problems arise in those frames that the model don't detect an object. And in those frames, what I would like to do is I would like to use the bounding box of the most recent frame that the object is detected. So in order to recall the bounding box of the most recent frame that the object is detected, I would use two dictionaries. The first dictionary is to keep track of the check ID and the corresponding bounding box coordinates. The second dictionary is to keep track of the check ID and the frame number, where the frame number is the most recent frame that the check ID was detected. So if we are at a frame where the model doesn't detect an object or a check ID was not detected, we will refer to the most recent frame in which check ID is detected, and we also extract the bounding box coordinates from that frame. So here I need to import namespace, which is used to store the attributes for ByteTracker, which is the checker that I would use. So the input into ByteTracker need to have attributes XYWH, confidence score, and classification index. So this class is to prepare the input that will be fed into the ByteTracker. So here is the main function, inference. The input is just the part of the video. First, we read the video using cv2.video capture. We extract the video features, width, height, FPS, and number of frames. So here we might want to print out those features, and here we create a codec for writing output frame. And next we will have a few dictionaries that will be used to store the most recent check ID together with the corresponding bounding box and the frame number. So the first dictionary I called history. It is used to store the check ID and the corresponding bounding box for that check ID. Frame history here is used to store check ID and frame number, where the frame number is the most recent frame where check ID is detected. I set buffer to 30. Buffer means the maximum number of frames we should have to retain the information. So here, min box equal to 2. This is the minimum number of box to draw in every frame. Last min results is the last result which detect at least 2 boxes. So here I also want to handle the case where in one particular frame only one person is detected and the other person is not detected. So only one bounding box will be drawn on the detected persons. So whenever such case happen, I will refer to the last frame in which both of the person are detected. So that last frame will be reflected in this variable last min results. In order to activate ByteTrackers, we need to form the arguments in the form of namespace. So here we pass in the variable check high thresh, check low thresh, match thresh, new check thresh, check buffer, and view score. Check high thresh is the value in which whenever we exceed this value, then we will initiate or we will accept a new check. We either initiate a new check or we connect it to an existing check. If something is between low and high, we need further processing. Match trash means if we have a new bounding box and that new bounding box match with the old bounding box up to IOU 0.7, then we say that the two bounding boxes are the same. New check trash means we only initiate a new check whenever we have a number that is higher than this. So you can look at the original documentation for the meaning of these values. Buffer means the number of frames that we use to retain the information without deleting a check. And here is the command for initiating a checker. So we will loop through the frames. And I also have one variable to count the number of frames, that is frame number. So here we will loop through the frames and read every frame. If we don't have a successful read on some particular frame, we will print out the frame that we failed to read and increase the frame number, move on to the next one. Here we will call the detect large function to extract large objects from the current frame. If the number of detection on this frame is less than min boxes, where I set min box to 2, which means if we have less than 2 detection, we will assign result to be the last min results. Otherwise, we will update the last min result to the results. Next, we will prepare the input that will be passed into the checker. So XYWH here is simply the bounding box coordinates in the format XYWH. Note that the result here is a list of lists which have formed XYWH confidence score and classification index. So the bounding box coordinates are the first elements in the list, first 4 elements in the list. Let's come back here. So we check bounding box as the first 4 elements in the list, confidence score as the 5th, and classification as the last. Checker inputs will be a class instance result with these attributes. In order to check the current frame, we simply call checker.update of the checker inputs. So this check frame will have output as x1, y1, x2, y2, which are the bounding box coordinates in the form top left, bottom right, followed by the check ID of the current check, score, class, and index. So whenever we check successfully, which means the length of the check frame is bigger than 0, now we can extract the result. We can extract the check ID together with the bounding box coordinates. We will update the history with the current check ID and bounding box. So we loop through the check IDs and bounding box and we update the histories. We also update the frame history so that the check ID is matched to the frame number. We will remove the check IDs and bounding box that were not seen in the last 30 frames because we only want to keep up to 30 frames. So we loop through the histories. If the frame numbers of some check ID is less than the current frame number minus 30, we will delete that check ID from both history and frame histories. So the rest is to draw the bounding box based on the history, which means based on the check ID together with the bounding box coordinates. So we just loop through histories, we draw the bounding box, that is CV2.rectangle, and we put text, which is the check ID. And after that, we simply write the frame and increase the frame number to 1. And once we reach the last loop, we just release, cap, release out, destroy all windows. And here, let's run these functions. But let me rerun from the beginning, because whenever I call this result on Jupyter Notebook with show equal to true, I will need to restart the kernel. I'm not sure what is the reason. So here, let's call these functions. So now it's already running. We can see that for our video, it has resolution 1920 and 1080 with 196 frames. Well, note that in the codec that I use to write the output frame, I set a lower FPS, actually just half FPS of the original video, so that we can observe in a slower motion about how the objects are checked, how bounding boxes are drawn, and whether we miss the drawing of the bounding box on any frame. Okay, so here we already finished the process, and note that the last 6 frames we failed to read the frame. I'm not sure what is the reason here. In fact, I spent quite some time figuring out the reason and try to fix it, but I couldn't. So here, let's go to the output and observe it. So you can see, based on this output, both of our original problems are solved. Here we only check the main object in the frame, and we can see that in every single frame we draw a bounding box to the main objects, and furthermore we do not draw any bounding box on the audience. That's the end of my video. Thank you and see you next time.